My second job in conjunction with Boiler Trust here. We've got two of the Viessmann Vitocel 300s. These are the A+ rated. I believe they're the only A+ rated cylinders available. Could be wrong. Maybe someone can correct me. Is trombone museum with all the press fit connections. Expansion vessels in here. Now I'm not sure about this. I've been told that these don't any longer come with the flexible connectors, but they do. And they don't come with a tee-off connection for them. So still waiting for confirmation on that. Discharge systems there. Here we've got slave tank and our mains boost system, AquaBoost V2000 from Stuart Turner. And of course, standard, the Viessmann 200. Now I love this feature of the displays at the top of these boilers. Now when I come into the boiler room, I'm going to stoop down on the floor, struggle to see the displays. This is a normal height for operation, which is perfect. Under here we've got the normal things, so we've got plate separation. These are the new plates that I picked up from Antares, and you can see these bolt straight on the bottom of the boiler here. So what I've done is given a slight tweak of the angle to those connection pieces to get the same width as the plate. And this is a through and through plate, so none of that going around corners, mucking around, straight through, out on the side. I've got two pumps pumping in parallel. So these are 2580s. So I've got double the flow and a maximum of 8 meters head available for those pumps. The building is about 30 meters high, and the pump head has got nothing to do with the height of the building. So for those that tell me it is, try and explain to me why the heating is working on the top floor of this block with an 8 meter head pump. Mr. Combi, if you're listening, my radiators are not within 8 meters of the pump. So there you go, looking good. This nice new conduit that I picked up for the pumps, just to go on the wires. I quite like this little feature. Sensors there, so we've got the low loss header sensors. These are run from the EMP1 relay boxes. So each boiler has got one of these relay boxes, and for some reason Viessmann require one of these to allow us to connect in the pump and the secondary flow sensors, or low loss header sensors, as they would be if this was low loss headers. These heat exchangers are both 40 kilowatts. The boilers are 32 kilowatts. So that's on AMTD 10. So we should be getting somewhere below 10. So at maximum load, we shouldn't be dropping off too much on our maximum flow temperature. This is the old pipework that we've connected into here. And a couple of really big old cooker boilers in here, open flue jobs with fan dilution and everything else. This nice guy has come in and put in the isolation tap there for us. So we're down to a normal ticket for the testing of the gas there. Now this is interesting. Look, this is actually an open vented system. There's a expansion tank mounted on the side of the building, external, where it can freeze up. So the system's under gravity, and we were not offered the opportunity to change too much. We only got the plant room. So we brought the cold feed and expansion into our system. But these aren't actually acting as our primary safety devices for this system, because they're going to freeze up, and when they freeze up there'll be nothing. So I've put in a backup expansion vessel here for the odd days it freezes, and that forms our new neutral point. That's on our return, and pumps are just on the flow here, and we've fitted on both systems a 3-bar pressure relief valve here. So we've got a secondary sealed system, safety system here, as well as the open vented system. So the pressure at the moment in the system there on that side is going to be about 2.5 bar, probably about 2.5 bar to 3 bar actually, considering the height of the building, and fed by the external tank. The boilers themselves You can see how busy we were under here. So we've put the filling valves in over here on the returns from the cylinder, and it doesn't actually matter if they're on the flows or the returns actually, but they're on the loops from the cylinders. And because the diverter valve in the boiler is now on the flow on the 200 instead of on the return, that's going to give us water coming in through the return on the hot water when we top up, which allows us to blow all the air out of the heat exchanger through the little drain cock on this side. And that's it. Now this has got new functions in the controller. The new controller here we have in the hot water function. Here we have the hygiene function, which we've set daily. So this is going to be the Legionella function at 230 daily, and that runs the bronze circulation pump there and ramps the hot water temperature up really high and cooks all the pipe work and the cylinders to kill off any bacteria and germs. And, that's that one. Normal thing, it's all weather comp. Set up for weather comp, no internal reference points, and it's set for 24 hours a day to 21 degrees. So this temperature is irrelevant. Set to 21 degrees, and that's 24 hours a day at 21 for this building. Now obviously we're waiting for some feedback on that to see what temperatures we get, but we'll wait and see. That's it. Our new function on this boiler that's a bit different to the old ones for people who haven't fitted that many of these is that before, if you had the weather comp set and you'd set the temperature for say 21, if the outside temperature raised above 22, it just switched everything off, switched off the heating, switched off the pumps and everything. But that function's been replaced and now it's preset to 25. So irrelevant of what temperature it is, if it's over 25 outside, the boiler switches into standby mode. And this caught me out today because I was trying to commission and I wanted to just run the boiler, make sure everything's working. And I set the room temperature to 37 and the boiler wouldn't fire. And I thought I'd jiggered the boiler up and it wasn't working, and I rung technical, they didn't know. And luckily we had the phone number of one of the local engineers who had found this problem. And what we had to do was take some ice blocks, which we had for some cold drinks on the job, and pack them around the outside sensor, which luckily it's just the other side of that hole, so we could get to it. Pack it in ice blocks, cool it down to the point that the boiler would operate for us to test it, which is a bit daft. But there is a parameter setting inside the boiler you can go into. You can actually set that to 35. So you won't have a problem on a day over 35. So we were okay today. Failing that, you could put a 20k ohm resistor across the terminals for the outside sensor, and that would fool it into thinking there was an outside temperature of 10 degrees, and you could test the boiler then. But I don't know why they've changed this, and I'm a little bit annoyed about it, to be honest. It was nice. It worked fine before, as far as I'm concerned. I don't understand why they've changed it, and I wish they hadn't. So I think that's everything. Yeah. This battening system was something I saw another guy do on a job and I thought was quite good. We didn't buy enough ply to ply line the whole place. I think that would have been a better job if we'd ply lined everything. But we had this batten idea and we've copied that, so we just run battens down the wall. These pick up any clips on your horizontal runs, and at any point you're going down, you put these cross battens in, which actually you can mount on top of the other battens. They don't need to be set back in the wall like that. They can actually run across the surface, and just mount your Munson rings on those. So, okay.